Alright, we had some technical difficulties. We're trying to figure out the proof of the area of a rhombus. The area is 1/2 d1 plus d2. I went through and kind of labeled everything. We know all four sides are congruent, so I gave them one congruency mark. BD is a diagonal. I said that BD is going to be diagonal 1. And half of BD is going to be half of diagonal 1. The other half is going to be half of diagonal 1. AC, because they are perpendicular bisectors of each other, AC is cut into two sections where they're 1/2 of diagonal 2. Now, to find the area of the first triangle, triangle 1, you'll get 1/2 times, since it's a right triangle, leg 1 times leg 2. Leg 1 is 1/2 of D1, and then we're going to multiply that by 1/2 of D2. So what we'll get is 1/2 times 1/2 times 1/2, 2 times 2 times 2 is 8. So that's 1/8 D1 times D2. So that's triangle 1. Now, triangle 2 is congruent to triangle 1, so logically it makes sense that the area of triangle 1 is equal to the area of triangle 2, so that's going to be equal to 1/8 of D1 times D2. Now, the area of triangle 3 is going to be 1/2 times the legs, because again it's a right triangle. Just so happens that it's 1/2 of D1 times 1/2 of D2, which is the exact same thing as before. So it's 1/2 of D1 times 1/2 of D2, which is 1/8 times D1 times D2. And since triangle 3 is congruent to triangle 4, area of triangle 3 is equal to the area of triangle 4, which is equal to 1/8 D1 times D2. Now, if the total area is equal to the sum of the four triangles, 1, 2, 3, and 4, and they all have the same area, we can say it'll be 4 times 1/8 D1 times D2, because repeated addition of the same value, and we've already determined that 1/8 times D1 D2 is the formula for the area of all four triangles. Repeated addition of the same thing is multiplication. This is going to be equal to 4/8 times D1 D2, which is equal to 1/2 D1 D2. So therefore, the area of a rhombus is equal to 1/2 D1 D2. I apologize for earlier technical difficulties, but thankfully it was just putting in the things that we know about the cut or the rhombus itself, and we'll get this answer. Go ahead, try this for a kite. See what happens. I'm pretty sure you'll get the same thing, since the equation is exactly the same. So, enjoy!